Mathematics 1, Specimen Examination Paper 2017, Question B6. Solve the following simultaneous equations using Cramer's method. The first thing we have to do is to rewrite the simultaneous equations in matrix form. So we take the coefficients of the x terms, the y terms and the z terms and put those in a 3x3 matrix. Then we have a vector of the x and the y and the z, and that is equal to the constants on the right hand side. And just to review, if you took the x, y, z here and put them across the top here and multiplied them out, you get 2x plus 4y plus 6z is equal to 22. You get 3x and so on. So the next thing we need to do is to work out the determinant of the 3x3 matrix. So before we do that, let's review how to calculate the determinant. To calculate the determinant of a 2x2 matrix, you multiply A11 by A22 and subtract from that A12 times A21, so that we get D, the determinant, is A11 times A22 minus A12 times A21. To find the determinant of a 3x3 matrix, you start with the top left term. You remove the row that it's in and the column that it's in. And then you have a 2x2 matrix. So you multiply A11 by the result of the 2x2 matrix. Then you do the same again with the second term, removing the row and the column, giving you a 2x2 matrix. And then you do the same with the third term. So you remove the row and the column and you've got a 2x2 matrix. There's one other thing I need to mention, which is that we have this changing of signs. So the first term and the third term remain unchanged, and the second term is in effect multiplied by -1. So if the second term is positive, it will become negative. If the second term is negative, it will become positive. So now we end up with A11 outside a bracket containing A22, A33 minus A23, A32 minus A12 outside a bracket containing A21 times A33 minus A23 times A31 plus A13 outside a bracket containing A21, A32, A22, A31. And there's our determinant for a 3x3 matrix. So getting back to our problem, we're going to get 2 outside a bracket containing -3 times 5 minus 4 times 5. And then we're going to get -4 outside a bracket containing 3 times 5 minus 4 times 2. And then we're going to get 6 outside a bracket containing 3 times 5 minus -3 times 2. And if we evaluate that, we'll find that the determinant is equal to 28. The next thing we need to calculate is the x determinant. We'll call it dx. What we're going to do is we're going to replace the x column with the values from the right hand side. So that 2 becomes 22, that 3 becomes 4, and that 2 becomes 19. Then we calculate the determinant in the normal way to give us dx is equal to -84. For the y value, we replace the y column with the values from the right hand side and calculate the determinant, and the same for the z values. So we've now got d is equal to 28, dx is equal to -84, dy is equal to 28, and dz is equal to 112. Now to find x, we divide dx, which is -84, by d, which is 28, giving us an x value of -3. To find y, we divide dy by d, which gives us 1, and z is equal to dz divided by d, giving us a value of 4. So that's the answer to part A. Part B says, show your answers are correct. Well, the quickest way to do that is to put our values for x, y and z into any one of these equations. I'm going to take the first equation, so we've got 2x plus 4y plus 6z, which is 2 times -3 plus 4 times 1 plus 6 times 4, 2 times minus 3 is minus 6, plus 4 is minus 2, 6 times 4 is 24, minus 2 gives us 22. So our answer is correct.